Well, this problem looks new. I don't think we've seen anything like this before. In the past, we split up our numerators to simplify an integrand so that we can integrate each piece. But you're not allowed to split up denominators. That's not a rule that fractions allows. So the only thing we can do is ask the question, do we know any functions whose derivative look something like this? And you may or may not recall this, but the derivative of an inverse tangent function, or an arctangent function, does look like 1 over x squared plus 1, or 1 over 1 plus x squared, as we have over here. What this means is that the integral of 1 over x squared plus 1 dx is inverse tangent of x plus c. And that is a fact that we can just remember from here on out. How do we use this fact to solve this problem? Well, we can pull a 6 out of the integral. If we'd like, we could also write 1 plus x squared as x squared plus 1. And now integrating this gives us the inverse tangent of x, and we need to evaluate that from 1 to the square root of 7. The fundamental theorem of calculus, part 2, says that we just plug our upper limit into this, subtract, and then plug our lower limit into it. And while I don't think we can evaluate the inverse tangent of the square root of 7 exactly, this is a good chance for a reminder of what the inverse tangent means for this piece here. An inverse tangent is an angle whose tangent in this case is 1. If you think back to your unit circle, tangent is sine over cosine, which is a y value over an x value. So you'll notice that at this angle pi over 4 here, our tangent value is 1. You take that and divide it by that, and you get 1. So the inverse tangent of 1 is pi over 4. We will find no such angle on the unit circle whose tangent is the square root of 7. So we can just simplify this piece of the answer and box it up and call that problem complete. Good job. See you in the next one.